Okay, welcome to some extra work on bar graphs and histograms. If you just look at this first screen, you notice on the left we have a bar graph, just straight up bar graph, and on the right we have what we call a histogram. So just to refresh the differences, you can see in a histogram the bars touch, and that is the big piece. In a bar graph there is space between, and that is because when you look at the one on the left, score out of 10, if you're on a quiz, you can get a 1, maybe you can get a 1.5, but it's not continuous. You can't get a 1.4632, on, on. It doesn't work that way. But on this one, on the right, you can see how it's in intervals. So anytime we have intervals, we will have a histogram. Histogram is also good for continuous data, and that means like ages, or time, amounts of liquid, anything like that would be histograms. Okay, so we look on, we're on page 354, if you have the packet, and we are going to start by working on frequency tables. So this middle piece, total number of students, is the frequency, right? How many? And this is how I usually do it. 58 goes here, 79 here, 81 here. Okay, now I want you to hit pause and finish this out. And this proportion on this side, I'll talk about that when we come back, but just do the totals frequency first. Okay, so you can see how I did tallies and then I totaled them up. Now, if you don't want to do tallies and you want to go straight to the final number, that's fine. Just always make sure that your total number matches how many you started with. So if you know, always count these. I had 20, so my total here should be 20. That's super important to double check. Now, when you're finding the proportion implies it can be a fraction, so this would be 2 out of 20, because that's the total, which is also 0.1. So in terms of decimals, right, we would divide, in this case, this one is also 2 by 20. Then we get 6 divided by 20, which is 0.3. This one is the same, so 0.3. Then I get 4 divided by 20, which is 0.2. When you add the proportions, you should end up with 1, which is the same as 100%, and that works because we are talking about all the data. So you've got to make sure that your frequencies total to how many you started with, and then your proportions add up to 1, because that's important. And then we're going to use that information to create a histogram of the frequencies. So when you create a histogram, we've got labels, and if you're on page 354, this is already kind of set up for you. But you're going to put, you've got your intervals, 70 to 79, 80 to 89, whoops, and then 90 to 99. And what does that represent? Well, these are the score intervals. So you always want to have labels. And then on this side, I went by twos, 2, 4, 6, 8, and this is the number of students. So you always want to label it. And now that it tells you it's a histogram, we say, okay, 2 people were from 50 to 59. And then 2 people were from 60 to 69. Okay, those should be the same height. And then 6 people were here. And then 6 people were here. And 4 were in our last one. And these should all be the same. Now, I want you to go ahead and, with that in mind, and notice my bars all touch because it's a histogram. And I want you to do a histogram for the proportions. So do the same thing, hit pause, do your proportion, then come back and check mine out. All right, so I got it drawn here, and you'll notice that the only thing that really changed is this spot over here, because now it says proportion of students, and it's decimals instead of the numbers. But when you look at it, when you compare what your graphs look like, it looks pretty much the same, right? Well, it should, because you have the same data, you're just reporting it differently. And that's the important piece to understand, is that you can record data as actual numbers, which is what we did in the first one, right? We had the actual number of students. And in the second graph, we have the proportion of students. And so it depends what you want to talk about, right? This second one with the proportion, we could talk about 10% of students are score between a 50 and a 59, or 20% score between a 90 and 99. But On this one, where we had the number of students, you can't say 10% or 20%. You could say 2 students score between 50 and 59. So it's the same data, but you would talk about it differently. And now let's answer a few questions. What portion of the students passed the test with at least a D? Now, at least means a D or better. So your grading scale, and actually you could say, well, it depends on the grading scale, and that's true. But at Ivy Tech, a D is a 60. So we're talking 60 or better. Well, if you go back to your data and you count them all up, 18 people scored a 60 or better. So 18 out of 20 would be a 0.9. Or you could have simply, let me go back to my frequency table. You could have said it's these frequencies, and you could have added those together, which again would get you 0.9. Whoops, wrong thing. Okay. How many students earned? So now this question says how many. So now we're looking for an actual number, not a decimal answer like we had in number 1. So between a 70 and 90. So how many? So we know that 6 people score between 70 and 79, and then 6 people score between 80 and 89. And we want between that, so we would add those together for an answer of 12. 12 people did. All right. Now we have another example. I would like you to hit pause and try the rest of this. When you come back, I'll have the frequency table done. We'll talk about that, and then I'll move on to the chart. But go ahead and try. This is all on page 355. So try this, then come back and check out the answers. Okay, so notice I've got 14 total, so hopefully you go back and count, and there are 14 numbers. And so when I find my proportion for 17 to 21 degrees, I would take 4 divided by 14, which is 0.29, and we want to round. I would go to at least 2 decimal places. 3 probably would have been better, but let's be serious, I'm kind of lazy. So 2 is fine, 3 is better. And then when you add them up, hopefully you get something close to 1. If you round, it's possible that you'll be off from 1 by just a little bit, but that's not horrible either. Okay, so now we're going to go and make the graph. Okay, so you can see I have my intervals on the bottom, and I have my label, temperature intervals, and then I've got the frequency on the side, because it does say a histogram of the frequencies. So I know there are 4 in my first box, and I have 2 in the next 2, so they would be equal. And then the third one, 32 to 36, jumps all the way up to 6. That's crazy. And we know it's a histogram because you can see they all touch. So then we can answer some questions. How many days were freezing or above? So that's 32 degrees or higher. And the question says how many? So we're looking for the actual number, the frequency. So it's just 32 or higher, so that's just the answer to that one, which is 6. Now in 4, what proportion of the days were freezing or above? So now we just go over, right, and we have the 6 divided by 14, which we know to be 0.43. So it's important that you pay attention to the details. What are they asking for? Number 5, what proportion of the days was the temperature 31 degrees or below? So that would be the 17 to 21, the 22 to 26, and the 27 to 31. We want to add all of these together, and it says proportion. So if you think about it, that's 0.29 plus 0.14 plus 0.14. And my answer would be 0.57. And then the question that says how many days were in the teens. You can't answer this by looking at your frequency table because your frequency is 17 to 21. Well, 20 and 21 are not teens. They're the 20s. So you've got to go back to your chart and look, and the answer to this question is 2 because we have an 18 and a 19. So that one you have to just go back to your data. And now, what proportion of the days were in the teens? What proportion? Well, that's 2, and we know we had 14 days total, so 2 divided by 14 is simply 0.14. And there's the answer to that one. And I believe that is the end of the video for bar graphs and histograms. Thanks.